Thank you very much, Alberto. May I invite our other two speakers to come up to the table? And then I suggest we take a round of questions, and Alberto can also join us. We will pick up 2, 3, 4 questions, and then go from there. And as you ask a question or make a comment or a suggestion, please tell us your name and institution. And if you've addressed it. Sir, we have a microphone, so you can tape.
Peter Davies, Jefferson Fellow at the State Department. A question to start off with to Winston. You're classifying your materials as nanotech. Are you referring to the size of the clay particles, the silver particles, or the size of the pores? And a second question, having sat through several slide sets from EPA and CDC, I'm very concerned about the toxicity of silver nanoparticles. Do they leach out of your pots? Do they get into the environment? And if so, what effects might they have?
Why don't you hold on one moment? Let me see if we have other questions. If not, then we go over to you, Winston. Okay.
Sure. Thank you. So the sizes of the pores are bimodal. So you have some pores that are nanoscale pores and some that are micron scale pores. So the key to trapping the pathogens is how carefully you can control those pores. In addition to that, when you fire the clays, you leave some activated carbon on the surfaces that also have nanoporous structures. The colloidal silver or the copper nanoparticles that you use are also on the nanoscale. And you can control the amounts of these to levels that are really very low. So you do get some leaching, but the leaching levels are well below any levels that are of any concern. So in reality, we feel that this is a controllable structure that is on a nanoscale. It turns out that there are other things that go on at the nanoscale that we are now beginning to try to understand, because we find, for example, some of the surfaces absorb viruses due to the presence of iron oxide in particular. So unlike other things that I do in my lab that are much further along and very difficult to customize at the nanoscale, we're able to control these in an environment that's not necessarily very expensive to produce.
Thank you very much. While I wait for our colleagues to shape their minds and their thinking, I myself, Winston, have a question for you. And I apologize that this is a naive question, but does it matter, one question, does it matter what type of clay it is? In the sense that do you also have to transmit that knowledge? It is a naive question. And the second question I have related to that was also, you mentioned you took a lot of pride in this not being, quote unquote, a lot of imported materials. And for this to be more accessible in rural areas across Africa and so forth, does it matter about how to get the silver or the bronze, silver or copper that you mentioned? How much are they locally accessible? And my last question is, in the uptake, and you gave those wonderful examples of the chief hiding the underneath the bed and so forth. Did the participants recognize a difference in taste? Did that matter? Was taste at all and part of the equation in terms of, we were focusing on the safety, but how in terms of the uptake, did that matter at all?
You're going to show that I'm suffering from some mental issues of forgetting things, but I'll try. So I think the first one was about the clay. So it turns out that the clays have different plasticity. And if you want to form the shapes, you need to have the clays being plastic enough so that you can form them. And so there are two ways you can go. You can go the Western material science way, which is to measure plasticity in ways that you can do by mixing up the clays and looking at silica alumina ratios. Or you can use empirical methods that local people have also developed to measure plasticity. So one of the key aspects of the work is to have the ability to do some measurement of plasticity on a factory level. And we've done this. With that, you can then use almost any clay mixed with the right combination of plasticizer to allow you to be able to form these locally. Now, in terms of sort of the firing characteristics, it also turns out that you can now build local kilns that can take you up to the temperatures that you need to reach. And if you do those experiments, they're about 850 to about 900 degrees centigrade. And those are doable on a village level. Now, why this becomes important is that if you buy commercial kilns for these kind of rural operations, those commercial kilns are quite expensive. They increase the risk associated with the business quite a lot. If you start burning diesel, which a lot of them do, the volatility in diesel prices also increase the volatility in the potential filter prices. So by taking the time to figure out a little bit of the clay plasticity and how you can use local materials, you really stabilize the businesses. I think I forgot the middle question.
The other question was on the taste.
The taste is essentially normal taste. You don't have an aftertaste after the first two filtrations. So what tends to happen is after you're fired, we recommend that you filter at least twice to remove all the residual materials. And essentially the taste is acceptable to local people.
And the silver and the bronze, that's not an issue.
The silver levels are very small.
Copper, yeah.
And the copper is also very small. So if you look at the levels that are leached, you know, they're in sort of very, very low parts per million. They're really very low to the point where they're not a concern. Mm-hmm. And the dipping levels are also low. Now, in the creation of an enterprise like this, just to put it in context, if you have to buy the silver for a year's supply, it will probably cost you $1,000, which is about $1 per pot at most. And if you scale it and you do things, you can go even lower than that. It turns out that in the overall scheme of things, if you could then produce these locally, then it becomes very interesting. So one of the reasons why we teamed up with local universities is that often there is a big disconnect between local universities and real technologies that actually happen. And so we think that this might be an interesting example of doing something in a reasonable time scale where you can show that the knowledge that they bring to the table actually adds value to the sustainable technology.
Thank you very much. You raised quite a lot of different issues there, not just on the science, but on the marketing side.
Yeah.
Let me come over and see if any of our, I see a hand at the back. Yeah. And Alberto, please also feel free to raise your own questions to our other two panelists.
Thank you. I'm Takara with the USDA Foreign Ag Service.
Speak into the mic.
I'm with the USDA Foreign Ag Service. I just had a quick question. I'm really curious to know about the life of these ceramic pots. How long do they last before they need to be replaced?
Sure. Can I answer?
Go ahead.
Yeah, they last 2 to 3 years. During that time, the flow rate reduces as the pores become clogged, and you just have to replace the ceramic pot. So that's the scientific answer and the business answer. The truth is, if you reheat these and you reverse flow, you can extend those lives by another year or so or two. But they do eventually get clogged, and by clogging, I mean the flow rates become so slow that you choose to replace them.
Okay. Yeah.
I'm Rob Neuter with IFDC. I have a question for Alberto, and that is, you've shown some good data on the zeolite effects on fertilizers as well as the animal feed. What are some of the practical problems challenges and opportunities associated with making this a more commercialized type of application?
Alberto, did you get the question? Kwong, I don't think he's hearing. Or we can't hear him.
Sorry, can you repeat? I could not listen.
Or maybe does he need to come and speak from here?
Can you hear me now?
Yeah, now I'm here.
Okay. This is Rob Neuter with IFDC. My question is, based on the data you have shown, you are achieving very positive results. The question I have is, what are some of the practical challenges and opportunities to making this zeolite inclusion a commercial reality?
Okay, now we are carrying out some field tests with some formulations of fertilizer, joining the zeolite or the bentonite with mineral fertilizer. We already have in our research team some arrangements between IFPRI and Petrobras, our petrochemical industry that produce urea in Brazil, to find a commercial formula for this zeolite plus urea. And we have some smaller companies trying to join this technology. We are very excited with this possibility, and many field tests are being carried out. And industry is together with us in this research project to find how to mix this. Of course, all of this technology are in lab scale and in the pots experimentation, and probably we need to scale up this technology. So we also trying to the contact with IFDC. I personally was in Navispi last month to try to develop this technology for these new fertilizers.
Address, yeah. Okay.
Science question for Winston. If you, if I could stop you from typing. You indicated that you can get bacteria to make your nano silver and nano copper particles. If these particles are lethal to bacteria, can you explain how the bacteria can make them?
That's a good question. So what we've is that some of the things secreted by the bacteria when they interact with certain salts can result in the nucleation and growth of nanoparticles. And
From solution?
they're secreted into solution in a biochemically controlled environment. And we've been studying these in a range of systems, and we find this quite fascinating. The precise mechanisms are being worked out, but we show basically we can form nanoparticles that range from a couple of nanometers to up to maybe 100 nanometers. And we're now in the process of trying to play with these nanoparticles. And this is not just us, but there are a number of labs across the world where people are finding the controlled formation of these. It turns out that the morphology and the concentrations of these are highly dependent on the pH that you use. And we're again trying to understand this. We can form spheres, pyramidal, plate-like, rod-like structures. And we think that this could give us what I would call a village-level way of producing nanoparticles for different functionalities, especially in some of these applications where setting up a full-scale chemical plant might be difficult.
How come it doesn't kill the bacteria that are producing it?
So it's an interesting question. So the first part is you have a salt, and you go through a series of chemical processes to create another material, right? And so once you produce that material, your question is how come you don't then have a sidal effect, right, on the cells? And that's something we haven't studied.
There's a question back there. Yeah.
There are three questions actually.
Okay.
First, is the same species of bacteria you're talking about, or is it two different species?
Oh, there are different species of bacteria, not just
I
one.
guess that's the reason for why. I don't
Yeah.
know. And then this.
Can you tell us your name and institution?
Oh, sorry. Caroline Cruz. I'm a USAID Bureau of Food Security. And then I have a question for Alberto. Do you have any data about the fungal biomass with using the zeolites and the phosphorus?
Unfortunately, no, we do not have this data. Our focus was just in the dry matter yield or grain yield of these crops, and we carried out some chemical analysis from the substrate. We do not have any results about biomass or microbiology from the soil.
Is the intent to do it in the future, or no at all?
I don't think he heard you.
Alberto, did you hear the question? She asked whether you intend to do it in the future.
Yes, this research is being continued. As I told you, we have some experience being established now in our summer season, and probably one of our colleagues from our research team can be interested to do something like this.
Okay. Obrigada. And then my last question, sorry, is for Guillaume. Is that right? Can you expand a little bit more on the use of nanoclates to ameliorate the aflatoxin? Thanks.
Not sure I can expand much on that, but yeah, because we reviewed a lot of different applications. But my understanding is that you had it to the. So this is the nanoclay for aflatoxins. If you add it to the feed, it was reducing aflatoxin. I don't remember exactly how it was applied, but I could check. I'm sorry. Because we reviewed a lot of them with my two colleagues, and so I don't feel comfortable talking about it. Can I add a couple of questions for my colleague, though, for my co-panelists? One is for Winston. I would like to know what happens. So you said we have to renew those part of the filters after 2 to 3 years. So what happens to those the clay that you can't use anymore? That's so clogged. Do you see it? Could you actually recycle it in one way or another, or is it something you've considered? And then for Alberto, just one question. Last question is, Alberto, you didn't talk so much about how much does it cost to extract those zeolites from the sedimentary rock. Do you have any numbers on that, or have you done any study on that? Thank you.
Let's go first to Winston.
Sure. So what we do is we recycle these into building materials. So it turns out that by linking the clay filter production to building material production, there are many advantages. So one of these is any rejected stock you recycle into building materials, and used stock you also recycle into building materials. And that sort of gives you an incentive to continue to do so.
Mm-hmm. Alberto? One moment.
All the problems that we have with the beginning of this. Is it okay?
Yes, go ahead.
Thanks. All the problem was that we showed the potential for the use of the natural Brazilian mineral, but we do not have a mine to extract zeolite in Brazil. We have some regions where we know that the mineral, of course, and there isn't yet a mine where we can extract. So it led us to change the focus of the research, trying to find another available mineral. So we are beginning to work with bentonite. That is a very not expensive mineral, and with high availability here in Brazil. About the cost of this mineral, the imported zeolite we can buy here in Brazil approximately by the same price of the urea. For us, actually, 1 ton of urea can be by around $750 per ton. I think the imported zeolite we can buy by the same price. The bentonite we can buy by the half of this price, around $300 per ton of bentonite. If we use about 20% in the formulation, that's our best results. We can dilute a bit of the nitrogen concentration for the formulation. But we put a low expensive material that can increase the nitrogen use efficiency, for example. So we have some advantage there. The best results showed that 20% of zeolite, almost around this for bentonite, was the best result.
Thank you very much. Let me wrap up the session now. And before I do that, I'd like to say I myself found this session fascinating. I took away, Winston, the combination from your presentation of both the advances in the science and the application of that science with the importance of having marketing strategies and strategies for education were very important elements that really come together, and in a sense it helps to address some of Guillaume's questions at the very beginning. So in moving from concept to reality, it is not just the reality of the science, but also the reality of education and uptake that need to go hand in hand. I'll be very intrigued, to see how the health community responds to this scientific innovation in the sense of how they see addressing the challenge that you laid out. And Alberto, yours is a fascinating presentation too, and the multiplicity of uses that you identified, and the scientific advances there. But then I was also very intrigued when you mentioned right at the very beginning of your presentation that the zeolite found in so many natural formations, and the opportunity there to move from the science to the application in the field, and the potential of not just from Brazil, but for many countries that have similar, not only challenges, but topographies also. I'll be very intrigued to hear also then the role of the application there and the role of education there. But Guilherme, I think at the end of the day, this helped to address the question that you started out with. 3 years ago, we were very much still talking concept. Now the applications, and then the challenge will be how, it can do all these applications, should they be treated the same? Be very curious 3 years later where we are. Thank you all very much for joining us, and I hope that you will continue to follow the work of our presenters, particularly Winston and Alberto, who are really applying this, drawing the applications from the science to the household. Thank you very much.